So we're going to look at another way to factor using a special pattern. We already talked about the special pattern called difference of squares and another one called difference of cubes. This time we're going to look at the sum of cubes. And again, the thing is, a sum is things that are added together, so we'll be adding. And then we need to have two things that are cubes. So 125x cubed I present to you as something cubed. If you want to pause the video and try to figure it out yourself, that'd be awesome. I also say that 1 is something cubed. So I'm going to go ahead and rewrite those guys as something cubed. Hopefully you beat me to it and you realize that if I multiply 5 times itself 3 times, I get 125, and then x times itself 3 times is x cubed. So I must have 5x cubed when I have 125x cubed. Plus, it turns out that 1 is really itself raised to any power. So 1 can be itself raised to any power. All right, then, once we have that established, we're going to use this formula that you see over here, a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. And again, in order to use that formula, we have to recognize that one of these guys must be called a, and one of these guys must be b. And I'm going to call 5x a, and I'm going to call the 1 b. So what we'll do is we'll plug in those things. We'll plug in 5x wherever we see a, and we'll plug in the 1 wherever we see b. So here we go. It's going to be a is 5x, then we have a plus sign, then 1 is b, and then we start the next parentheses, and then a squared. That's 5x times 5x. That'll be 25x squared. Then minus, that's right there, a times b, 5x times 1, simply 5x, and then finally b squared. So plus, let me make that a little prettier there. There we go, plus 1 squared, which is just 1. So that's it. We were able to factor. Now the next thing is we'll go ahead and we'll continue by setting that equal to 0. In the last example, all we did was factor, but one of the reasons we factor is so that we can solve. And when we go to solve, for this guy, we'll use something called the zero product property. And the zero product property, the ZPP, which again, you should Google zero product property if you can't remember what it is or you're not sure how it works. What it means is that if I take a factor like 5x plus 1 and multiply it times this other big factor and they equal 0, then either 5x plus 1 equals 0 or this other stuff equals 0. Now, if 5x plus 1 equals 0, it's pretty easy to solve that equation and just figure out what x is. I'm going to say from my experience, it looks to me like x is going to be negative 1/5. Okay, but then getting figuring out setting 25x squared minus 5x plus 1 equal to 0, that's going to be trickier. And in fact, it's not factorable, so don't even try. When you look at this formula is presented to you in this way. It's supposed to be pre-factored. That's why we have a plus b times this other stuff. So this other side is never going to be factorable. It's never going to be. But you still can, if you set it equal to 0, you can still solve. The way you have to do it is using quadratic formula. And the other bad news that I have for you is that we're going to get complex solutions. So let's give it a try. Why not? I'm just going to remind you guys that the quadratic formula looks like this. X equals, this thing. And so we're going to need the quadratic formula here in order to solve this guy. Remember, a is 25, b is negative 5, and the c is 1. So we'll just plug them in there and we'll hope for the best. So here we go. So we'll say x equals, and by the way, technically we're supposed to put whatever, if this was a t or a d or something else, we would put that there. That's what we're solving for. So negative b is going to be, well, b is already negative, so that'll be positive 5, and then we'll do plus or minus, and then we will take the square root of b squared. When we do the b squared, always make sure that you use parentheses. In this case, it's negative 5. If you type into your calculator this, negative 5 squared, it's going to give you the wrong result, and you'll have no way of knowing. Humans, you need to use your brain before you ever touch the calculator. Write it like this, enter it in the calculator like this, the calculator will calculate it correctly. Next, minus 4 times. We got to do a and c, so 25 times 1, and then finally all over 2a, and in this case a is 25, so 2 times 25, and now we got to just keep on crunching along. Alright, so the next step is we're still going to do 5 plus or minus, and then this will be positive 25 minus 100, and so that'll be negative 75. So I'm going to put the square root of negative 75, and that's all over 50. And you might recall what happens when you have a square root of negative 75. Why don't you pause the video for a moment and see if you can put this in simplified radical form. Don't forget, you end up getting an imaginary number, okay? All right, hopefully you did it, and now I'm going to show you what I think. I don't know if I can do 75 right off the top of my head, so I'm just going to do a quick 5 times, well, let's do something really easy. I know 3 times 25 gets me 75, and this is 5 times 5. So it must be something like the square root of 5 times 3, break that in 2, I get 5 root 3. So now because there's that negative sign out in front, it's going to be oops, I screwed that up. We said that we would always put the number, so I'll put 5, then then root 3. That's the better way to write it, and then all over 50. And then we'll have to use some skills that we've discussed in the past where we break this into 2 fractions and then simplify. Now, you can also factor out the GCF, and I'm going to show you that method because I'd like you guys to be masters at factoring the GCF. So there's a 5 here and a 5 here. I'm going to factor out that 5. That'll give me 1 plus or minus I root 3 all over 50. And when I factor out that GCF, I can now cancel this 50 with this 5. I cannot cancel the 50 with this 5 or with this 5. I could cancel it with both, but it's real easy to get that wrong. It's better to either break it up into 2 fractions or factor it out and then cancel. It is perfectly legal now to go ahead and cancel this 50 with this 5. It leaves me with 1 up here, and then I've got 10 down there. And now I can go ahead and finish this guy off. Let's go ahead and write the final answer. It's going to be x equals 1 plus or minus I root 3 over 10. And I want to remind you that the answer on the test might look like 2 separate fractions, so it could be 1 over 10 plus or minus, let's do this, square root of 3 over 10 I. There we go. So that's a possibility. And then we'll box that, and that's it. So now I want you to notice there's really 3 answers here, okay? I've got 2 roots here because that plus or minus, and I want you to notice that the 2 roots are complex, and then over here I've got 1 more root that I solved for earlier, and that's real. But notice that my degree of my polynomial, notice my highest power is 3, and I have 1, 2, 3 roots. I always get the same number of roots as the degree of my polynomial. Sometimes some of them are complex, and sometimes they're all real. All right, that's a good example of sum of cubes. Oh, one last thing I'd like to say since I just brought up sum of cubes. We've talked about difference of squares and we talked about difference of cubes. Now we're talking about sum of cubes, and some of you might be wondering, well, how come you never mentioned sum of squares? So I want to remind you difference of squares is a special pattern. When we have something squared minus something else squared, we can factor into a minus b times a plus b. So what I'm wondering is whether you think we have a formula for this. I was hoping, don't write all this stuff down. I just want you to think about it for now. And I want you to take some scratch paper, and I'd like to see if you could come up with the formula for a squared plus b squared. You're going to pause the video, and then I'm going to tell you what the real deal is. Okay, now I'm hopeful that you're not being sneaky and that you actually did pause the video. Here we go. It turns out that to factor a squared plus b squared, this is what you get. Yeah, sorry. I hate to be the bearer of bad news. If you suffered a little while you were trying to factor that guy, that's okay. That's good for you. The struggle helps you to remember. So anyways, yeah, there is no special pattern for sum of squares. There's just no easy way to factor this guy. So we're going to stick with difference of squares, difference of cubes, and sum of cubes.